Hello students, welcome back to the maths class. In our last class, we have discussed some concepts about surface areas and volumes. We have gone through some examples and we have solved some questions those are given in your book. In today's class, we will discuss some more concepts about surface areas and volumes. Okay? Students, let us now discuss exercise 13.6. Question number 8. It says a patient in a hospital is given soup daily in a cylindrical bowl of diameter 7 cm. If the bowl is filled with soup to a height of 4 cm, how much soup the hospital has to prepare daily to serve 250 patients? So students, let us discuss the solution for this question. So students, as per the given data, diameter is 7 cm. That means radius will be 7 by 2, that is 3.5 centimeter. Okay, and the height of the cylindrical bowl is 4 centimeter. So h is 4 centimeter. So let us find the volume of cylindrical bowl. So volume is equal to pi r square h, that is equal to 22 by 7 into 3.5 square into 4, that is 22 by 7 into 35 by 10, 35 by 10 into 4. 7 5s are 35, 5 2s are 10, 2 11s are 22, 2 5s are 10, 2 2s are 4, 5 7s are 35. So that is equal to 11 into 14, 154 centimeter cube. Okay, so the volume of the cylindrical bowl is found to be 154 centimeter cube. That means the amount of soup the hospital has to prepare daily for one patient is equal to 154 centimeter cube. For one patient, volume of soup is equal to 154 centimeter cube. So students, for 250 patients, that will be equal to 154 into 250, that is 38500 centimeter cube. And we know that 1 centimeter cube is equal to 0.001 liter. So that means 38500 centimeter cube is equal to 38500 into 0.001, that is 38500 into 1 by 1000 or 38.5 liter. So for 250 patients, the hospital has to prepare 38.5 liter of soup daily. Okay, hope you understand the solution for this question. Students, let us now discuss about volume of a right circular cone. Okay, as you can see in figure 13.28 that is given in your book, there is a right circular cylinder and a right circular cone of the same base, radius and the same height. Students, try to make a hollow cylinder and a hollow cone like the figure given in your book with the same height and same base radius, as you can see in figure 13.28. Then you can try out an experiment that will help you to see practically what the volume of a right circular cone would be. Okay? Students, fill the cone up to the brim with sand once and empty it into the cylinder. You will find that it fills up only a part of the cylinder, as you can see in figure 13.29a. When you fill up the cone again to the brim and empty it into the cylinder, you will see that the cylinder is still not full, as you can see in figure 13.29b. When the cone is filled up for the third time and emptied into the cylinder, it can be seen that the cylinder is also full to the brim, as you can see in figure 13.29c. With this, we can safely come to the conclusion that 3 times the volume of a cone makes up the volume of a cylinder which has the same base radius and the same height as the cone, which means that the volume of the cone is 1/3 of the volume of the cylinder. So, we can write it like this: volume of cone is equal to 1/3. What is volume of the cylinder? That is pi r square h. So, volume of cone is nothing but 1/3 of volume of cylinder, that is 1/3 pi r square h, where r is the base radius and h is the height of the cone. Hope you understand this. Students, let us now discuss example 15. The height and the slant height of a cone are 21 centimeter and 28 centimeter respectively. Find the volume of the cone. Let us now discuss the solution. As per the given data, the height is 21 centimeter and the slant height is 28 centimeter. So, we know that r is equal to square root of L square minus S square, that is 28 square minus 21 square root over. Okay. And when we calculate, it will be 7 root 7 centimeter. So, the radius of this cone is 7 root 7 centimeter. So, what should be the volume? Volume is equal to 1/3 pi r square h. That will be equal to 1/3 into 22/7 into 7 root 7 square into height, that is equal to 21 centimeter. That is equal to 1/3 into 22/7 into 7 square into 7 into 21. So, that is 22 into 49 into 7, and that is equal to 7546 centimeter cube. Okay. So, this is the volume of the cone. Hope you understand the solution for the example. Students, let us now discuss example 16. It says, Monica has a piece of canvas whose area is 551 meters square. She used it to have a conical tent made with a base radius of 7 meter. Assuming that all the stitching margins and the wastage incurred while cutting amounts to approximately 1 meter square, find the volume of the tent that can be made with it. Okay. So, let us discuss the solution. Students, area of canvas is given as 551 meters square. So, area is equal to 551 meter square. Okay. And area of the canvas lost in wastage is 1 meter square. So, the used area is equal to 551 minus 1, that is 550 meter square. Okay. Now, the surface area of the tent is equal to 550 meter square. The required base radius of the conical tent is 7 meter. So, r is given as 7 meter. Note that a tent has only a curved surface. The floor of the tent is not covered by canvas. Okay. Therefore, curved surface area of tent is 550 meter square. So, curved surface area is equal to 550 meter square. Fine. That means, what is the formula for curved surface area? Pi r L. So, pi r L is equal to 550 meter square. So, 22/7 into 7 into L is equal to 550 meter square. So, students, that implies L is equal to 550 divided by 22. 11 2s are 25 meter. Okay. So, students, L is found to be 25 meter. Now, we know that L square is equal to R square plus S square. Students, we know that L square is equal to R square plus H square. Fine. Now, what is h? h is equal to L square minus R square root over. Okay, that means 25 square minus 7 square root over. 625 minus 49 root over, that is equal to, yes, root over 576, or that is 24 meter. Okay, so the height is 24 meter. Now let us find the volume of the conical tent. Okay, so students, what is the volume? Volume is equal to 1 by 3 pi r square h, that is 1 by 3 into 22 by 7. What is r? It is 7. So 7 into 7 into 8. What is height? Height is found to be 24. So 22 into 56, that is equal to 1232 meter cube. Okay. So this is the volume of the conical tent. Hope you understand the solution. Students, let us now discuss about exercise 13.7. Let us solve question number 1. What it says? Find the volume of a right circular cone with radius 6 centimeter, height 7 centimeter and radius 3.5 centimeter, height 12 centimeter. Okay. So let us solve the question. For the bit 1, what is the radius? 6 centimeter and height is 7 centimeter. So r is equal to 6 centimeter and h is equal to 7 centimeter, and we need to find the volume. So what is the formula for that? 1 by 3 pi r square h. So volume is equal to 1 by 3 pi r square h. 1 by 3 into 22 by 7 into 6 square into 7. So 22 into 6 by 3. This is equal to 22 into 12. So 264 centimeter cube. Fine. So for bit 1, the volume is 264 centimeter cube. Let us now solve for bit 2. Okay. For bit 2, radius is 3.5 centimeter and height is 12 centimeter. So volume is 1 by 3 pi r square h, that is 1 by 3 into 22 by 7 into 3.5 square into 12. So students, this becomes 1 by 3 into 22 by 7 into 35 by 10 into 35 by 10 into 12. That means 7 5 jar, 5 2 jar, 5 2 jar, 5 7 jar, 4 3 jar. That means 22 into 7, 154 centimeter cube. Okay. So the volume of the second cone is found to be 154 centimeter cube. Hope you understand. Students, let us now solve question number 2. It says find the capacity in liters of a conical vessel with first radius 7 centimeter, slant height 25 centimeter and second height 12 centimeter, slant height 13 centimeter. So let us solve the question. Students, for bit 1, the radius is 7 centimeter and slant height is 25 centimeter. So r is 7 centimeter and L is 25 centimeter. Okay. So to find out the volume, we need to have the height. So let us find the height. H is equal to square root of L square minus R square, that is square root of 25 square minus 7 square, that is 625 minus 49 square root of 576, that is 24 centimeter. So height is found to be 24 centimeter. Hence volume is equal to 1 by 3 pi r square h, that is 1 by 3 into 22 by 7 into 7 square into 24. That is equal to 22 into 56, and 22 into 56 is found to be 1232 centimeter cube. So, in first case the volume is found to be 1232 centimeter cube. Okay. Now, this is the volume. So, we need to find the capacity of the vessel in liters. Okay. So, let us find out. Students, for bit 1 volume is found to be 1232 centimeter cube. So, let us convert it into liters. So, this is equal to 1232 divided by 1000, that is 1.232 liter. So, the capacity of the vessel for the bit number 1 is 1.232 liter. Hope you understand. Now, let us solve bit 2. Okay. Students, for bit 2 the given data are height and slant height. Okay. So, for bit 2 height is equal to 12 centimeter. So, h is equal to 12 centimeter and slant height is given as 13 centimeter. So, L is equal to 13 centimeter. Let us now find out the radius. So, R is equal to square root of L square minus S square, that is square root of 13 square minus 12 square, 169 minus 144 square root of 25, that is 5 centimeter. So, the radius is found to be 5 centimeter. So, volume is equal to 1 by 3 pi r square h, that is 1 by 3 into 22 by 7 into 5 square into 12. So, that is equal to 1 by 3 into 22 by 7 into 25 into 12. That is 22 into 25 into 4 by 7. So, when we calculate, it is 2200 by 7 centimeter cube. Let it be like this, because we are going to find the capacity. So, let us find the capacity in liters. Students, volume is found to be 2200 by 7 centimeter cube, that is equal to 2200 by 7 into 1 by 1000 liters. So, 11 by 35 liters. So, the capacity of the second vessel is found to be 11 by 35 liters. Hope you understand. Students, let us now solve question number 3. It says the height of a cone is 15 centimeter. If its volume is 1570 centimeter cube, find the diameter of its base. Okay. And the instruction is given as to use pi as 3.14. So, let us solve the question. So, for question number 3, what are the given data? The height. Height is 15 centimeter and the volume is also given. Volume is 1570 centimeter cube. So, students, that means 1 by 3 pi r square h is equal to 1570. That implies r square is equal to 1570 into 3 divided by pi into h. What are the value for pi and h? 1570 into 3 divided by 3.14 into height is given as 15. So, 3 5s are 15, that is equal to 1570 into 100 divided by 314 into 5. So, 5 20s are. So, 1570 into 20 divided by 314. That means we can cut it out 314 because 314 5s are. So, 25s are 100. So, r square is found to be 100, that implies r is equal to square root of 100, that is 10. So, radius is found to be 10 centimeter, but the question asks for the diameter, not the radius. So, d is equal to 2 into 10, that is 20 centimeter. This is the required answer for the question. Hope you understand. So students, let us solve question number 4. It says, if the volume of a right circular cone of height 9 centimeter is 48 pi centimeter cube, find the diameter of its base. So let us solve the question. So what is the given data? Height. Height is 9 centimeter and volume is given as 48 pi centimeter cube. 48 pi centimeter cube. That means 1 by 3 pi r square h is equal to 48 pi centimeter cube. We can cut pi from both sides. So r square is equal to 48 into 3 divided by h. That is 48 into 3 divided by 9. So 3 3s are 9. 16. So r is equal to square root of 16, that is 4 centimeter. But we need the diameter. So what is diameter? D is equal to 2 into 4, that is 8 centimeter. So this is the required answer for the question. Hope you understand. Students, let us now solve question number 5. It says a conical pit of top diameter 3.5 meter is 12 meter deep. What is its capacity in kiloliters? Okay. So let us solve the question. As per the given data, diameter is equal to 3.5 meter and deep, it is the deep, that means it is the depth. Depth is nothing but your height of the pit. So height is equal to 12 meter. Fine. What is the radius? That is d by 2 or 3.5 by 2. Fine. So it becomes 1.75 meter. So now we have radius and height. So let us find the volume. Volume is equal to 1 by 3 pi r square h, that is 1 by 3 into 22 by 7 into 1.75 into 1.75 into 12. Okay. So when we calculate, it gives us a value that is 38.5 meter cube. Okay. Thus, what is the capacity then? So capacity is nothing but capacity is equal to 38.5 into 1 kiloliter. Why is it so? Why 38.5 into 1? Because 1 meter cube is equal to 1000 liter or 1 kiloliter. That is why 38.5 meter cube is equal to 38.5 into 1 kiloliters. That is 38.5 kiloliter. Okay. Hope you understand. Students, let us now solve question number 6. It says the volume of a right circular cone is 9856 centimeter cube. If the diameter of the base is 28 centimeter, find height of the cone, slant height of the cone and curved surface area of the cone. So students, let us now solve the question. Okay. So as per the given data, diameter is 28 centimeter. So radius is 28 by 2, that is 14 centimeter. And the volume is given as 9856 centimeter cube. Okay. So 1 by 3 pi r square h is equal to 9856 centimeter cube. So 1 by 3 into 22 by 7 into 14 square into h is equal to 9856 centimeter cube. That implies h is equal to 9856 into 3 into 7 divided by 22 into 196, because 14 square is 196. So student, after calculation you will get a value that is equal to 48 centimeter. So the height of the cone is found to be 48 centimeter. This is the answer for bit number 1. Let us now solve for bit number 2. Okay. Radius is 14 centimeter and height is found to be 48 centimeter. So let us find the slant height. So slant height will be square root of r square plus s square, that is square root of 14 square plus 48 square. Fine. So this is 196 plus 48 square is 2304. Square root of 2500, that is equal to 50. Okay. So slant height is found to be 50 centimeter. Hope you understand. Now let us solve bit number 3. Okay. Students, bit number 3 asks for the curved surface area. So what is the curved surface area of a cone? That is pi r l. That is equal to 22 by 7 into 14 into 50. Okay. So 44 into 50. 2200 centimeter square. So curved surface area of the cone is found to be 2200 centimeter square. Hope you understand. Students, now we have come to the closure of today's class. In this class, we have discussed some more concepts about surface areas and volumes. We have gone through some examples. We have solved questions from your book. Hope you have understood all the concepts clearly and the solutions for the questions. You need to practice all these questions and the examples as well, so that you can have a good grasp on all these concepts. Okay. So keep practicing and keep smiling. Thank you.